Welcome to Math with Faith. Today we are going to start our discussion on number bases, and we're looking at converting any number in any other base to base 10, which is what we count in, right? So number bases refer to how many numbers we have in a particular system of counting, right? That might sound weird because we normally count in base 10. And base 10 has 10 numbers. And if you count them, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 to 9 and 0, that's 10 numbers in base 10. There are other number systems with other number bases. It could be more, it could be less. We have base 16, which we call hexadecimal, right? Where we have 16 numbers, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9, we start with some letters, A, B, C, D, right? That's 16 numbers altogether. So you could have more than 10 in your base, or you could have less than 10. What's the purpose of bases? Well, for example, in a computer system, right, where you have to code everything with on and off. That's two states. So whether something is on or off, that will determine what its output will be. You have to know how to convert everything into zeros and ones. 0 meaning off, 1 meaning on. So you only have two states, and everything has to be done with that number system in mind in terms of programming, right? So that's one example. Another example is base 60. Everybody knows base 60. We count base 60 all the time. Where do we count that all the time? We count that in minutes, because there are 60 minutes in an hour. So that's actually base 60, because we're counting up to 60, and then we count into 59, and then we start again, 0 to 59, 60 numbers. We have base 24, there are 24 hours in 1 day, so we have to count in 24s when we're talking about days. So those are some practical ways of looking at number bases. A system that has 5 numbers, for instance, is in base 5, right? If you have 5 numbers, you are in base 5. What those 5 numbers would be? 0, because remember, we always start our number systems with 0. So it will be 0, 1, 2, 3, and 4. Those are 5 numbers. 1, 2, 3, 4, 5 numbers. Right? So base 5 will not have the 5 in it. It will have up to 4, 0 to 4. So let's look at counting in base 5. So just like we use all our single digits in base 10, and then we go to 2 digits. So after we used up all our single digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we have to go to 2 digits. We start with 1 in our 2 digits, right? 1, 0, which is 10, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc., etc. Same idea for base 5. Remember, we don't have 6 and 5 and 6 and 7 and 8 and 9. We only have up to 4. So when we get to 4, we have to start our 2 digits, right? So we do the same in other bases. So in base 5, we count the bottom numbers here. 0, 1, 2, 3, 4. There is no 5 in base 5. So we have to go to double digits. 1, and we start back counting 0, 1, 1. We don't say 10, 11, 12 when we say it in other bases. So we call it 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. We don't have 1, 5. So we have to go to 2 in our double digits. So 2, and then we go to 0, 2, 1, 2, 2, 2, 3, 2, 4. All right? Now we don't have 2, 5, so we have to go to 3 in our double digits. And then we go 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. And we don't have 3, 5, so we go to 4. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. When we get to 4, 4 now, we don't have any more. We don't have 4, 5. And we don't have any 5 to go to. So that's the end of our double digit. So now we have to go to 3 digits. So again, our first 3-digit number will start with 1, 0, 0. Because now we're going to start all the way from here. 1, 0, 0, 1, 0, 1, 1, 0, 2, 1, 0, 3, 1, 0, 4. 1, 1, 0, 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, 1, 2, 0, 1, 2, 1, etc., etc., until we get to 4, 4, 4. And then we have to go to 4 digits, right? So I hope that is very clear how we count. Now, on top here in the purple, you will see what this is. The bottom shows us base 5. These are how we count in base 5. The top shows us base 10, how we normally count. So 1, 0 in base 5 will be 5 that we would, because remember we go 0, 1, 2, 3, 4, 5. So 1, 0 in base 5 is 5 in base 10. 1, 1 in base 5 is 6 in base 10, etc., etc. Right? So that's how we count in base 5. So let's look at counting in base 3. Now remember, we only have 3 numbers in base 3, which wouldn't include 3. It will be 0, 1, and 2. Those are our 3 numbers in base 3. So let's count in base 3. In base 3, we'll say the first number is 0, 1, 2. And we don't have any 3 in base 3, so we have to now go to double digits. We start with 1, 0, 1, 1, 1, 2. We don't have 1, 3. We have to go to the next double digit, which will start with 2. 2, 0, 2, 1, 2, 2. We have no 2, 3 because there's no 3 in base 3. So now we have to go to the next digit. But we don't have another digit either for the double digits. There's no 3. So now we have to go to 3 digits. 1, 0, 1, 0. Then 1, 0, 1, 1, 0, 2. No 1, 0, 3. So we go to 1, 1, 0. Right? Just like we had 2, then 1, 0. We have 1, 0, 2, and then 1, 0, 1, 1, 1, 1, 1, 1, 2. There's no 1, 1, 3, so we have to go to 1, 2, 0, 1, 2, 1, 1, 2, 2. There's no 1, 2, 3. We have to go to the next. No, it's not going to be 3. It's not going to be 3 because we don't have any 3. So we have to go to the next double digit, which is 2, 0, 0, next triple digit, sorry, which is 2, 0, 0, 2, 0, 1, 2, 0, 2, 2, 1, 0, 2, 1, 1, 2, 1, 2, 2, 2, 0, 2, 2, 1, 2, 2, 2. And now we are filled with the 2's. This is the final amount of 2's and the 3 digits. So we have to go to the 4 digits. 1, 0, 0, 0. Then 1, 0, 0, 1, 1, 0, 0, 2, 1, 0, 1, 0, 1, 0, 1, 1, etc., etc. And on top here, we see the equivalent numbers in base 10. So 2, 1, 0 in base 3 will be 21 in base 10, which is in normal base we counting. Now, instead of having to write out all those numbers, suppose I want 1,000 in base 10, and I have to write out 1,000 numbers in base 3 to find out what that is in base 10. No, we could convert from another base to base 10 by using expanded notation. Now, if you remember from primary school about expanded notation, what we used to do, we used to say, let me annotate, we used to say, we have this number 254, 254. We used to put this in our place values, ones, tens, hundreds. So if we expand this notation, this will be 2 by 100, because that's 2 in the hundreds column, plus 5 by 10, because it's in the tens column, plus 4 by 1, because it's in the ones column, right? That's how we used to do it before. But at this level, because we have to do it for other bases, we are not going to call them hundreds, tens, and ones. We are going to number our columns, right? It's going to come out to be the same thing, and I'll show you how. We are going to number our columns, right? So we number it from the last column out here. That will be column 0. So like your ones column, that last number in your number, digit in your number, sorry, that last digit in your number will be 0, right? Column 0, and then that other one is 1, and this is 2. Now, since this number is in base 10, 254, since this number is in base 10, we will be multiplying by 10 to the power whatever column it is in, right? So, for example, this number here is 2 multiplied by 10 to the power 2, right? This number here will be 5 multiplied by 10 to the power 1. This number will be 4 multiplied by the base of 10 to the power 0. Okay, so now let's look at this. 10 squared, 10 to the power 2. 10 to the power 2 is what? When we multiply by the power 2, it means you have to multiply 10 2 times. So 10 by 10. 10 by 10 is 100. So we get this is 2 by 100. See how we got this 2 by 100 here? Same thing, 2 by 100 plus 5 by 10 to the power 1. Now, what is 10 to the power 1? You're just multiplying 10 one time. So 10 to the power 1 is just 10. So that is 5 by 10. Just like here, 5 by 10. And here now we have 10 to the power 0. 10 to the power 0 is what? Well, anything to the power 0 is 1. So just remember that rule. Anything to the power 0 is 1. Anything to the power 0 is 1. So this is 4 by 10 to the 0 is 1. See how we got back that? Right? So we got back our notation, just that. Now we have to remember to call the columns 0, 1, and 2. And I'll tell you why. Because now let's look at 33 to the power 5. Now you can convert any base to base 10 by doing expanded notation, right? So let's look at 33. Now the base is now 5. So this is 0, column 0. Remember, the last column is the column 0 and then 1. So we have column 0 and column 1 here. So this number is 3 multiplied by the base of 5 to the power 1. This plus 3 multiplied by 5 to the power 0. What is 5 to the power 1? 5 to the power 1 is just 5. 5 multiplied once. 5 to the power 1 is just 5. So this is 3 by 5. And what is 3 by, well, what is 5 to the power 0? Anything to the power 0 is? Anything to the power 0 is 1. Anything to the power 0 is 1. So this will be 3 multiplied by 1. What are 5 threes? 5 threes are 15. 5 threes are 15. 5 threes are 15. What are 3 ones? 3 ones are 3. So 15 plus 3 will give me 18. So 33 or 3 in base 5 is 18 in base 10. And let's look at this. Let's go back up. Let's go back up. Look, we did the numbers in base 5 here. 33 in base 5. When we counted it, we got 18. See how we got the same thing there? Right. So 33 to the base 5 is 18 to the base 10. Hence, to change from one base to base 10, we do expanded notation. That's how we convert number from any base to base 10. Let's do 1 in base 3. 1, 1, 2, 1 to base 3. What's that in base 10? Again, we have to number our columns. The last digit is going to be column 0. This is column 1. This is column 2. This is column 3. So expanding this notation, this would be 1 multiplied by 3 to the power 3. So 1 by 3 to the power 3. The next one is 1 multiplied by the base of 3 to the power 2, because it's in column 2. So 1 by 3 to the power 2. This one will be 2 multiplied by the base of 3 to the power of the column 1. So 2 by 3 to the power 1 plus 1 multiplied by the base of 3 to the power of the column 0. 1 by 3 to the power 0. All right, so let's see what is 3 cubed. 3 cubed. That's 3 multiplied 3 times, right? 1, 2, 3. That's 3 cubed. So 3 3s are 9 multiplied by 3. That will give me 27. So 3 cubed is 27. And then we have 3 squared. What is 3 squared? 1 by 3 cubed is 1 by 27. Plus 1 by 3 squared is what? 3 squared is equal to 3 multiplied by itself. 3 2 times. That's what the squared means. 3 2 times. 3 by 3 is 9. So this will be 1 multiplied by 9 plus 3 by 1 is 3 one time. So just 3, right? So 3 by 1 will be 2 multiplied by 3. And what plus, 1 by 3 to the power 0. What is 3 to the power 0? 3 to the power 0 is anything to the power 0 is 1. So it's just 1 by 1. So that's 27. 1 by 27 is 27. 1 by 9 is 9. 2 by 3 is 6. 1 by 1 is 1. And when we add that up together, 27 plus 9 is 36. Plus 6 is 42. Plus 1 is 43 to the base 10. So we had 3s. We had to multiply by 3s here because our base was 3. Right? And that's, so this is the expanded notation for this number. And this is what it is in base 10. Right? And I hope that that is understood very well. Listen to the different parts of the video wherever you got confused so that it can cement in your mind and you can do the exercise well. All right, so that's how you can use expanded notation to change from one base to base 10.